Hello everyone, my name is Iiro Lindborg and welcome to this webinar. On this session I will be focusing on autonomous maritime and talking about the building blocks of autonomous maritime and also about the current state where we are at the moment, what's been implemented into commercial use and what's been currently developed as well. First of all, a couple of words about Krog Technologies. Krog Technologies is a company focusing on creating solutions that will reduce navigation crew stress and ensure peace of mind during operation, even in the most challenging conditions. And our product offering will start from situational awareness systems, which I'll be introducing to you later on in this presentation as well. First of all, I want to set the scene a bit for autonomy itself in respect to current maritime and what is the current situation. So as you may all be aware, the current fleet of vessels is in general older than 25 years old. And the average age of the commercial ships at the moment is 21 years. And to put things in perspective, what this means is that when the current onboard technology was installed in these vessels that are sailing today, Nokia 3310 was the coolest and the newest mobile phone. Broadband was being introduced to the homes and also the businesses. If you remember how broadband worked, it was this annoying noise that was made before connecting to any network. And at this time, when these vessels were new, Facebook, Twitter, and YouTube was not even invented yet. So these are the aspects that we should remember always when talking about existing vessels and also introducing new technologies as retrofits to these vessels. And as a comparison, I have put here two container ships. The one on top is APL England, which was built back in 2000. And the one below is HMM St. Petersburg. This one was built in 2020. And when you look at these two vessels, you can see that not much has actually changed, visually at least. But technology-wise, the changes have been quite drastic. But still, we have to remember that a lot of these new vessels still rely on quite old technology and the newest technology that we are using in our everyday life isn't something that's currently used on board. Many of you may remember, for example, the introduction of touchscreens when those were introduced to the vessels and so on, because that technology, for example, is not that common in these kind of ships either. So we have to keep that also in mind as a background information for when talking about autonomy. Then setting the scene a bit for autonomy. So because of the existing fleet's age and also the technology used on board today, full autonomy cannot be retrofitted to existing vessels. So there is no way of implementing solutions that would make the existing vessels fully autonomous and also, for example, fully unmanned. But we will most likely see crew supporting autonomy and automation functions and solutions installed as retrofits. Mainly the systems currently being developed are navigation related. Some also for machinery side, like condition-based monitoring that is supporting autonomy as well. But the main development focus is on navigation systems. Digitalization is something that is been talked about quite a lot. It's this kind of a hot topic at the moment. And digitalization as such is one of the aspects that will be helping autonomy when going forward. So the solutions implemented, the new digital solutions that are being implemented to vessels are helping then the introduction of new autonomous features and new autonomous operation models as well. And as mentioned, machinery side has been a bit out of focus in autonomy development and discussions, and to some extent also on the research side. But there are some initiatives looking into this, but not that much. Quite often we see that electrification is referred as kind of the replacement for machinery side when talking about autonomous ships. So it's just mentioned that we have the machinery on this vessel is fully electric and that's it. But it's not, unfortunately, as black and white as that. So also that side needs to be developed, and it needs some bigger efforts in order to be ready for autonomy as well. Then if we look at the one example from digitalization and how that is affecting autonomy and how it's an enabler also for new autonomous way of operations or new autonomous way of thinking. So here I have taken one example from current digitalization scheme. This is just-in-time operation, or JIT. The basic principle of just-in-time is that today's vessels are coming into port at wrong time, maybe burning a bit more fuel than intended, and then they just have to wait in anchoring before they can get berthing position and start unloading or loading cargo. And in just-in-time operation, the basic principle is that the arrival time is informed beforehand, and then the speed of the vessel can be optimized to that arrival time. So basically port informs when they can take the vessel in, and when they have all actors ready in the port, for example, for mooring, for loading, piloting, docks, and so on. And then also the vessel can inform port when they will actually arrive. So there's a lot of recent studies made on this topic, how much there is variation between the informed arrival time and the actual arrival time. And then there's also a lot of solutions looking at this and optimizing and predicting the actual arrival times. So when the arrival time is so-called just-in-time, there's a lot of actors who are gaining savings in this. One, of course, is the terminal operators, because they can then optimize their own resource use. Port authorities can optimize their own resources. Ship owners can have reduced turnaround times when it's more better planned and in schedule. Cargo owners will get benefits through reduced lead times. And then I think the main thing what is considered here is the reduced emissions, because by reducing the ship speed by 10%, this will lead into 27% reduction of the ship's emissions, which is quite significant difference. Then how all of this is linked to autonomy itself. Basically, just-in-time is one enabler for new type of autonomous operations. So with this approach, the controlling of a vessel can be changed from current way of propulsion and engine control actually, to mission-based control. What this means is that vessel will be just given, for example, an arrival time, if it's a general cargo vessel. And based on this arrival time, everything else happens automatically. All the waypoints, speed control, everything else, weather control or weather optimization and all that, everything is done automatically. And only thing that is of essence is the arrival time. Or it can be based on earnings. So for example, for tankers or other type of cargo, which is spot rate controlled, then you can have prediction models that are looking at the market space. What would be the most optimal time to arrive? And based on that optimal earning, then the arrival time is defined based on that. And we go from individual equipment control in controlling the whole mission of the vessel. Then when we look at the autonomous vessels, different building blocks that are needed in order for the vessel to be autonomously operated. This illustration is from Maersk Line. and it was presented back in 2018, but it's still valid. So we do have different systems that are linked, and all of these systems need to be in place for autonomous operations as well. So what is the current status and where we are with these different building blocks at the moment? On the control and optimization algorithm side, the situation is pretty good. There's a lot of companies doing different kind of algorithms for these, and I would say that these solutions are commercially in place already. Connectivity-wise, there are a lot of connectivity offerings, and a lot of different companies offering this side, so that's also in place. Situational awareness, there are companies offering this for autonomous vessels as well. Basically, a situational awareness system is a solution that is looking what's happening outside the vessel. Then one could say also that it's also situational awareness to look inside of the vessel. But for that side, there isn't that much offering, but for looking outside and what's happening around the vessel, for that side, there is offerings in place. Then we have a set of solutions which are in principle in place, but that are not necessarily ready yet for autonomous operations, or not built for that purpose. For example, electrical propulsion systems, we do have podded propulsions and solutions for those, and with batteries and so on. But as such, they are not necessarily ready yet for fully autonomous operations. So that side still needs a bit of work. Then we do have condition-based monitoring and predictive maintenance as well, but there the case is pretty similar. It still needs a bit of work in order to be fully ready for autonomy, so to say. IT infrastructures, there are a lot of different infrastructures in place already, but they may still need some reshaping and rethinking in order to be autonomous operation ready. For example, one thing is where would be, for example, control centers. What would be the locations? Would control centers be such that each company needs one? Or would those be centralized and you provide, or someone provides remote operation and autonomy monitoring as a service for shipping lines? So these are the things that are currently being discussed, and still no concrete solutions as such are in place. Of course, we do have companies who are operating remotely at the moment, but in order for this to be more globally adopted, it needs still a bit work. Then we have a couple of areas which I've highlighted that are not in place at the moment. One being real-time, stable and secure high bandwidth connectivity. Of course, one could say that we can rely on satellite connectivity, true, but if we need real-time data transfer, with satellite connectivity, there are certain delays that are introduced when you're sending data to satellite and back. And then also, in addition to that, it's not always so stable. And there are areas where it's very challenging to have connectivity. In this domain, there are a lot of companies working on, for example, low orbit satellites, which most likely will be a solution for this part. And then also one of the good things is that at the moment, for example, our normal life behavior is driving towards the need of 24/7 connectivity, and this then applies also to seas, because for example on large cruise ships, when you have a lot of passengers, they are used to having, for example, Netflix and applications like these which need connectivity. So the cruise ships are then obliged to provide this kind of connectivity, and that will then have a business driver for this kind of low orbit satellites and connectivity solutions like that. Then we have the reliable prime mover and auxiliaries. So machinery side, as mentioned earlier, is something that needs to be focused on also in future a bit more in order to be compliant for autonomous operations. And then also autonomous control systems. We do have demonstrations of these, but commercially not that much in operation or in place yet, but I think this is an area which is coming quite fast out of these other red areas. So this is being developed in a lot of different places and by a lot of different companies, and also it's also been researched quite a lot. So autonomous control systems are most likely coming out in quite near future. But yet again, those are still focusing quite much on navigation and linking the navigation to prime mover control. But then you still need the other part for that. So the monitoring and fault tolerance and what the system should do in case of breakdowns and how to still continue the autonomous operation. So that was kind of the building blocks why we are not in fully autonomous world yet. But then looking at what are the other issues at the moment. On the left-hand side, you can see the IMO definitions for an autonomous ship, which is divided into 4 different categories. So level 1 is automated processes and decision support. Level 2 is remote controlled vessels. Level 3 is remote controlled without seafarers, so that's remote control and unmanned. And level 4 is fully autonomous ship, which can be either manned or unmanned. One of the obstacles on introduction of autonomy has been the definition issues, because the definitions themselves are linked to many different things. One is the legal things, but then also the insurance and so on. So definitions have been an issue, and there are still issues on the terminology, for example, and one term can be interpreted in quite many ways. Then another issue is the absence of crew issues. So, for example, UNCLOS defines that all ships must be in charge of a master and officers who possess appropriate qualifications. And then we have SOLAS, MARPOL, STCW, and so on, which require that, for example, master is present on board the vessel always when it's moving and so on. So how this kind of definitions are addressed when the vessel doesn't have, for example, any crew on board. Who is the master? Who has the responsibility? And so on. So these are the things that are being looked at by IMO at the moment in their different conventions. Then we have the issues of navigation rules. For example, for the navigation rule, there is an expectation that all ships will be capable of executing maneuvers and steering in accordance with the basic rules of navigation as prescribed by the goal regs. The challenge with the goal regs is that there is clear indications how to behave in different conditions and different situations, but then there is also mentioning or you can follow good seamanship. What this means is quite fluffy, because it's not as such, it's not defined. So it gives quite a lot of room for interpretation. My personal taking on this is that we should change the thinking of autonomous vessel navigation. Because today a lot of the navigation is and the rules are depending on what we see and what we expect others to do, so we behave accordingly. But in my opinion, we should be moving more towards the principle from self-driving cars, where the main factor is that you tell everyone else what are your intentions and what are you doing, and then it's up to the others to adapt to that behavior. So in that kind of situation, everyone knows what the others will be doing. So then the situation is clear for everyone. No one needs to do any predictions on what the others might do. So this is the thinking change that I believe that should be happening when discussing the navigation of autonomous vessels. Then we have the issue of cybersecurity and connectivity, and as mentioned, there is at the moment no guarantee that there would be global connectivity. And also, what is the required level of, for example, cybersecurity monitoring and such? Those are still open issues. Then we have the issue of seaworthiness and error in navigation. So there are certain warranties that apply for vessels, and are linked to maritime insurance. So these should be taken into consideration when thinking these. And at the moment there's work carried out on insurance side, for example, on these, but still no concrete resolution is in place. And then of course, liability and the limitations. Who is liable if something happens? And the juridical side of all these things. Then when looking at the introduction landscape, so this is a threefolded illustration on that from University of Turku here in Finland. And in this illustration, it's looking at the outlook on the transition towards autonomous shipping. So on the first line, we have pull of future. And these are technologies and different topics that are pulling autonomy forward. And then we have the push of the present. So what things in present situation are pushing autonomy forward. But then the third part is the weight of the history. So these are the things which are then, on the other hand, pulling things down. So why things are not being implemented or moved forward with a faster pace. So as an example, we can take from environmental side. So new port infrastructures are pulling autonomy forward, and autonomy is being thought of in that context. Climate change is pushing new technology introduction, less emissions, going more for solutions that support the climate change initiatives. But then the current infrastructures are not built for these new changes. So these are pulling things down then again. So it's a balance of these three different factors that should be taken into consideration. And then when talking about the legal framework and the legal side of things and how things are complex. So one thing is that we have the national rules and regulations. And these are valid until the end of the exclusive economic zone. And after that, we go to IMO and international regulations. So that is the challenge of matching these two, so both the national rules and the international rules and regulations. And if the vessel is sailing between, for example, two countries and you have international waters in between, the vessel has to be compliant with both country rules and the international rules. If the vessel is only sailing within one flag state area, then it means that it only needs to apply with the national rules. So it can basically disregard international rules. But then in the end, more or less all the national rules are derived from the IMO international rules. So that's why they are relevant as well. Then autonomy, where are we now? So what has been done and what needs to be done, for example. So a lot of research have been done so far. The challenge quite often in research work is that it's focusing on one single topic. So quite often we have a lot of research carried out, like, for example, at the moment there's a lot of research for collision avoidance systems done. But usually they focus on one or two areas of that. So a larger perspective still needs to be carried out. Then, as mentioned, there's a lot of the regulatory hurdles. A lot of those the work has been started on those. There are working groups working on those. But it's a slow change. The process to change regulations in maritime takes about 15 years. So that is pretty long time. But the good thing is that the change work has started. And to date, it has taken 5 years to carry out the initial scoping exercise by International Maritime Organization. And now that is completed, so now the next step will be the rules themselves. So now they have defined what needs to be changed and what needs to be addressed. And now next step is then starting the change itself. But as mentioned, it is a long process. Then we have seen technology demonstrations. So we have seen that the readiness in technology exists, and that has been demonstrated. And the initial building blocks for autonomy are being worked on. So, for example, situational awareness systems are one of the first ones to be commercialized out of the required building blocks of an autonomous vessel. And then just on the right-hand side, you can see one example of research work looking into port arrival of an autonomous ship and how that process would work and what kind of different mode changes you would have on the vessel or its remote control. Then we can look at a bit on what are the current statuses on technology demonstrations and also what kind of solutions we have in place and in operation. And by in operation, I mean commercial operation in this sense. So I'm excluding for example, the naval and the military applications in this case. So focusing on commercial operation. So looking at technology demonstrations, we have the first remote controlled tugboat, the Switzer Hermod, was done in 2017. And then on autonomy, we had the first autonomous vessel demonstrated in 2018, the road ferry Falco. And then I will have a bit more details on both of these in the following slides. Then in operation, what we have at the moment, for example, we have remote controlled support of inland vessels. This is carried out by CFAR since 2018. And then as an example, we have the autonomous rocket recovery vessel by SpaceX, which has been in operation since 2020. Then looking a bit more on the demonstrations themselves. So the first remote control demonstration was for the tugboat Switzer Hermod, and on this vessel it was equipped with situational awareness system. Connectivity was carried out through mobile network, and then it also had remote control capability from land. In this demonstration, no payload equipment was controlled by remote control means. It was mainly for navigation and controlling of the propulsion of the vessel. And there was a demonstration carried out by Rolls-Royce in the harbor of Copenhagen. Then looking at the autonomous demonstration, yet again Rolls-Royce team carried out this retrofitted installation on board road ferry Falco in Finland, and the retrofit included situational awareness system, including radar and proximity sensors, autonomous navigation system that included collision avoidance functionalities, and then connectivity on this one as well was with mobile network, and then there was a remote control station fitted to this solution as well, from where the captain could remotely control or intervene the autonomous operation of the ferry. And as mentioned, both these demonstrations were carried out through cellular network, although in the autonomous vessel case there was also readiness for satellite connectivity, but the cellular network in this case was sufficient enough for remote control and video feed connectivity as well. Then in addition to these first demonstrations, there has also been other technology demonstrations and tests recently. In Japan, by 30 different Japanese companies, there is a project on designing the future of fully autonomous ship called DFFAS. And this was a demonstration of autonomous sailing and fleet operation center located in Makuhari. And there has been already some demonstrations on this project already carried out, like as an example, the Fleet Operations Center. Then Mitsui Shipbuilding, Furuno, and MOL Group are demonstrating autonomous sailing, including autonomous berthing and unberthing, also in Japan. And the demonstration vessel is using two different vessels. One is a large car ferry and the other one is 749-ton container ship, so demonstrating on 2 different vessels. And we have seen already the news on the autonomous berthing and unberthing of the car ferry earlier this year, so that has been successfully demonstrated. Then in Korea, Samsung Heavy are having a project called Samsung Autonomous Ship, and this is demonstrating remote control and collision avoidance of an autonomous vessel. To date, it's been demonstrated on a couple of different types of vessels. And then in Singapore, there's Smart Maritime Autonomous Vessel project with Bosch and their tugboat, the autonomy system from ST Electronic, and connectivity from M1 Limited. And the demonstration here is the demonstration of autonomous navigation with collision detection and avoidance, predictive maintenance, and remote monitoring and control of the vessel. And then last on this list is the Hyundai Intelligent Navigation Assistance System, demonstrated by Hyundai Heavy Industries, Korea Shipbuilding and Offshore Engineering Company, and Avicus Corporation. And the demonstration here is unmanned transatlantic voyage with a very large liquefied natural gas carrier. And this will actually be the world's first transoceanic voyage of Degree 2 autonomy defined by IMO. So this one will be very interesting to follow, and the location will be transatlantic as mentioned. Then in addition to these kind of technology demonstrations, there are also commercial uses where autonomous solutions or autonomy related solutions are being used. As mentioned earlier, CFAR is already operating inland vessels in Belgium, and at the moment they have 2 remote centers in operation, one in Antwerp and one in Rotterdam, and one is being set up in Charleroi, and all of these in Belgium. And then in the Flemish area. And then one is being set up, as mentioned, in Charleroi, and then they have at the moment 9 ships under management in these operation centers. And from the control center, the captain can navigate with direct control or just supervise the automated operation of these vessels. And of course, one of the challenges in European inland waters are the locks. So the vessels are being controlled and monitored also from the remote stations when they are going through the locks. Then we have the autonomous operations of SpaceX's rocket recovery platforms. A shortfall of Gravitas is the name of the vessel. And SpaceX actually has a fleet of 3 of these. One is a bit older one, and this the shortfall of Gravitas is the middle one, and the third one is currently being built, to my understanding. And these ships can drive themselves to and from port without crew assistance and without a tow. But at the moment they are usually towed out of the port. But then when they are doing the recovery operations, then they are autonomously operated and kept in place. And the foundation of these vessels is that they are converted from barge. Then other known commercial projects aiming at autonomy or remote control. 2, or maybe the most known ones, are the one of Masterly, the ASCO project, which is aimed to be the zero-emission autonomous vessel, which will replace trucks and will transport trailers across fjord in Norway. So the business case there is that instead of driving around the fjord with the trucks, the trailers are put into this vessel and taken across the fjord that way. Then there is the Yara Birkeland project, also by Masterly. That has been a lot in different kind of news over the years. It has been delayed slightly due to COVID and other issues as well. And the most recent news there is that it's the autonomous loading part will most likely not be part of the project. And so the cargo loading and unloading will be done in manual way like today, but the voyage itself, the sea voyage, will be autonomous. But there the aim is the same as with ASCO, so it's across the fjord instead of driving with trucks. Then we have the IntelliTAC project in Singapore by Wärtsilä, PSA and MPA. There the aim is to enhance capabilities of a harbor TAC by improving safety and efficiencies while reducing operator workload. And based on the information provided from the program, they are looking at, for example, enhanced situational awareness and also joystick-based control in some situations. Similar approach with ABB and Keppel on remote operated TAC with joystick control in Singapore. And there also the aim is to relieve the crew of tasks that can be automated, enabling them to perform at their best during critical periods of operation and enhancing the overall safety and productivity. Then third TAC project is with Kongsberg and Switzer. So this is continuation for the demonstration of remote control TAC that was carried out by Kongsberg and Switzer before, or Rolls-Royce, which is now bought by Kongsberg. And this one is aiming at developing TAC and needed technologies that can operate a TAC safely and efficiently from shoreside. So this is looking at fully remote operated TAC operations. Then we have Sea Machines and Damen. This is one of the most recent announcements, the Machine Odyssey, which actually started late September, their voyage. So they are demonstrating SM300 autonomous command and control system of Sea Machines on board the testing tugboat in Denmark. And I think it was 1,000-mile autonomous voyage that they are aiming for. Then in addition to these, we have Sea Machines and Rolls-Royce, who recently also announced their collaboration for yacht segments and looking at technology collaboration into this segment. Then we have Sea Owl in France. They are operating or looking at operating ROV mothership. So ROV's control would be moved to land-based control, and also the vessel which is launching ROVs would be remotely operated. And there the purpose is that they would be controlling the vessels from France, and the vessels themselves would be most likely in Angola or Africa region. Then we have Navigation Brilliance Technology, Dalian Maritime University and the China Waterborne Transport Research Institute, who are currently bringing autonomous container ship into commercial use. And the size of the vessel is 300 to 800 TEUs. TEU. So, and on the middle one on the right hand side, you can actually see the first vessel. And if I remember correctly, this one was the 300 TEU version. Then there's a lot of vessels which and projects that are in conceptual phase, like Power X in Japan, which is aiming at being the autonomous transportation platform for batteries between shore and wind farms. So the charging would happen in wind farms, and those high capacity batteries would then be transported to shore, and that would happen autonomously. This list is an indicative list, so in addition to these, there's also other projects, but these are just the most recent ones and the ones which have been in press recently. Then we can have a conclusion on recent activities and what has been done at the moment commercially and also on technology demonstration front. So what we can conclude is that it seems that remote control as such is slowly gaining traction, and that it is becoming, or there are commercial solutions that are coming into use. Then for the full autonomy, it still seems to be a thing of the future. So not that much full autonomous operation projects, but some are being prepared, like the Chinese project. And it seems that the current focus is shifting more to detailed technology and the utilization of more detailed technology solutions like collision avoidance. So there was a lot of projects that are demonstrating collision avoidance in near future. Then technology is still being verified. So we do see commercial projects, but not that many yet. So it's something to be looked forward, is this commercial use of autonomous technologies. And one thing to note as well is that although some years back there was a lot of discussion that autonomy will be enabling new radical ways of operation and new way of thinking and so on, but still I would say that majority of the commercial operations are looking at converting existing ways of operations into autonomy, and not so much looking at the possibilities that would be enabled by autonomy for more radical thinking and more of this kind of model changes. Then when going back to the building blocks of autonomy and looking at them, and which would be the first ones to be commercially implemented, and where the business opportunities actually lie at this stage. So there was a study carried out by SMM regarding the maritime industry, and one of the questions they had in their study was, which areas do the ship owners and operators believe would be the ones where we will see the increased digitalization and investments in what kind of technologies will be seen in future. So these are the answers, and there was 205 persons who answered, or companies who answered this questionnaire. And from these answers, we can look at, if we look at it from the situational awareness system point of view. So situational awareness systems are contributing into all of these categories. So as such, it's addressing a lot of the issues and a lot of the kind of hopes which are put on to the digitalization, and what digitalization is hopefully solving as well, and where it's linked to. So for example, for fleet management and performance, situational awareness can provide you fleet optimization data and can be linked to fleet optimization. It is assisting individual ships for optimized operations in that manner as well. It is helping in communications, so information sharing between shore and vessel, for example. Navigation and bridge management, for sure for navigation, situational awareness is essential system for future. It is linked to unmanned ships and remote control technology. It is basically an enabler of that. For digital twin, situational awareness systems are collecting loads of data that can be utilized in that aspect. And then also for the unmanned ship, it's one of the essential building blocks. So now I will focus a bit on situational awareness and what Krog Technologies is offering to market, and what kind of solution we are providing for our customers. It has to be said that our system is not commercially released for sales yet, but we are discussing with customers who are interested in situational awareness systems, and we are interested in hearing our customers' voice. And if you are interested in such solution, then please be in touch with us, and we can discuss further about the potential of having our system on board your vessels. So, situational awareness system as a building block for autonomy, but not only that, it's also there to monitor what's happening around the vessel, utilizing machine vision and object detection and object classification. And through the sense of fusion it creates, by utilizing multiple different data sources, we can provide information to the crew members what's happening around the vessel in real time, and this makes it easier for the crew members to make fast decisions based on facts that are at hand. Instead of looking for the facts and looking for information, the system will provide it to them instantly. So it's not just only a building block for autonomy, but it's also a system that helps today's crew members and vessel operations. So when looking at the challenges at sea and the common reasons for collisions today, uh, we have bad decision making, poor lookout, inefficient use of radar, inexperience, lack of communication between people at bridge, and fatigue. And to all of these factors, situational awareness is providing help and making things smoother and better. So then looking at few use cases and few comments from our customer discussions. So for example, one of the things highlighted by an onshore captain was that at night it's much more likely to get ships mixed up than during the day. And during the day you can specify a vessel as red ship, but at night all you have to go on is the ship's navigation lights. But for this AS camera sensors, so AS stands for awareness system. Awareness system camera sensors can track the vessel in day, low light and night conditions. So in our system, you can highlight the vessel and track it to avoid miscommunication between bridge crew. So this is enabling that side. Then one feedback from one crew member was that with the AIS and radar, what AIS and radar shows doesn't match one-to-one with what I see when I'm looking out. So younger crew members especially have a harder time telling which ship is which because of the delays in the system. With our system there is no delay, so awareness system shows detections and sensor data in real time, and that's the beauty of the sensor fusion. So although your radar information may be delayed, but because we are also in top of that adding what our cameras see, what AIS is providing, and we are fusing all that information together. So then we are matching everything in real time. Then regarding tracking and precision, a comment from one tugboat captain was that if the weather is too good, you can see too much and then become confused. So, for example, things that seem far away may actually be nearby. With the awareness system, what we give is precise distance of objects relative to your vessel. So we give the distance, and also we have certain features that will be alerting if objects are coming too close to you or are within your kind of safety area. Then feedback from a captain of a Japanese domestic vessel was that the 20-second information delay on radar means that you can't monitor small vessel movements or how their course changes. In these situations, I have no choice but to watch my field of vision. If there wasn't any delay, I'd be able to trust using radar only more. With the awareness system, as mentioned before, the movement is tracked and shown in real time. So we have tracking functionality, which is allowing us to track all the objects all the time and continue the tracking in changing conditions as well, no matter how fast the vessel is or the object. Then lack of detail. Yet again, feedback from a captain of a Japanese domestic vessel. Because of radar lag, using it to keep track of faster vessels is impossible. And as mentioned, AS system camera uses machine learning functionalities, and our system can track fast vessels or vessels without AIS, and then also determine if they are risks to us or not. So the system includes something called predictions, and these predictions are based on the movement and the pixel movement of the objects, and based on this we are then providing information where the vessel is heading, if it's a threat to us or not. So this works also for non-AIS vessels. Then again from domestic vessel, radar does not detect a ship's size. It makes them all the size of a cargo ship, even if it's actually the size of a fishing boat. Our system is equipped with something called object classification, which means that we are classifying the objects that we see. And from vessels, we can categorize them in 7 different categories. So cargo, tanker, passenger, fishing, tug, sailing, or motorboat or pleasure craft. And then in addition to that, we are also giving indication of the size of the object. In addition to classifying objects as vessels, we can also classify them as sea marks or other sea level objects in addition. Then when looking at how things are done today, so today for situational awareness, crews on board use ECDIS, radar and the bridge windows. In addition to this, what Krog is providing is the situational awareness system that is utilizing sensor fusion, and the information we are bringing into the sensor fusion includes radar, AIS, IMU, which is inertial movement, so pitch, roll, yaw, dual GNSS, chart information, and also camera-based object detection. And the cameras are both day and thermal camera, so basically day and night visions. And the sensor fusion information is then brought through a user interface to crew on board. And this is how it's in principle. So awareness system centralizes the inputs from different sources and uses sensor fusion to bring that information into one place. And then by utilizing the sensor fusion, we can identify threats accurately and quickly as well. Then how it works in principle. We have the information sources, the sensor fusion, and then from the sensor fusion, we provide display to user interfaces. And the user interface can be onboard, remotely used user interface, for example, like a tablet, or it can also be a remote user interface through our cloud system and in the office. So it can be either onboard system or onshore system. Then, what are the equipment we are installing on board the hardware? So we have the central unit, which is having all of our computing power in it. Then we have the camera, 225-degree camera for the day vision. And then we have the displays. So as a standard option, we have tablet-based displays, but we can also deliver fixed touchscreens or roof displays. Then I mentioned about our camera with the 225-degree field of view, and that is quite significant field of view actually when you think of it. So here's an illustration showing what is the field of view then and how much you can actually see. And to put this into perspective, I have an illustration here that is showing from our one of our pilot installations how big the view actually is and how much do you see from the camera. So this is one sensor unit that we install on board the vessel, and this is how much you can see from that. And our camera system is integrated with AIS, GNSS and other receivers, so it's one single unit outside that is handling all this. And in the same camera unit, we also have the thermal vision, which is 180 degrees. And from these illustrations, you can see, for example, the benefits that the thermal vision brings to also to the daily operation, so daytime operations. So basically, our camera system and the view that we provide through our user interface, it makes it really simple and easy to detect objects that are of interest and possible danger to you. And we can identify and track those easily in varying conditions. And this means that we can provide the crew with information that is needed and when they need it. So accurate information at the right time. And also we have multiple different views that can be customized for user needs as well. So then briefly looking at where Grog is going and what is our aim as a company. So at the moment, as mentioned, we are bringing the situational awareness system in the market, which will be the foundation of our solution offering. And we have developed a special camera just for this purpose. So this is developed for the maritime environment and autonomy in mind as well. Up next, we are looking at assisting even more the crews in navigation decisions and bringing them peace of mind during the operation, as we are with the situational awareness system. So we are bringing in more features to help the crews in navigation purposes. And of course, we are bringing out the solution that is already now then compatible for autonomous vessels as well. And we believe that this system will be one of the main foundational building blocks of autonomous vessel technologies. Then, to summarize and conclude, what is the future outlook for autonomy as such? So we believe that we will start seeing increasing amount of autonomous technologies being fitted to vessels. As an example, like I introduced, a situational awareness system. Then we'll be seeing maybe fully autonomous vessels, but there the big question is, does the industry want to change and go towards autonomy? We have to keep in mind that as it is now, the current way of operating and transporting is still the cheapest way. And most likely, unless that changes or there is some other external big driver to change that, there is no need for autonomy on ocean-going ships. Emissions are a big talking point, but will actions be taken on this? For example, utilizing autonomy as an enabler for reduced emissions. It will be interesting to see now, especially when the container transportation prices are going really high. Will those profits be used then for enabling new technologies to be introduced or not? That remains to be seen. Then COVID and the case Ever Given has opened a lot of eyes. For example, from cargo owners' point of view, they want to know where the cargo is and where it's going and what's maybe even the condition of it at the moment. And also, these incidents and the pandemic has opened a bit of the eyes of the industry to realize how fragile the system actually is at the moment. And there needs to be some changes on infrastructure level and starting from that when going forward. Then autonomous and remote controlled vessels, where the change will start, and what I believe will be the kind of first movers in this space. Short sea shipping, smaller vessels, shorter routes, easier legislation wise, and I believe that we'll be seeing a model shift in this domain coming up in the coming years. Short distance passenger and road ferries. By passenger ferries, I mean, for example, across river and this kind of short distances. These most likely will be adopting autonomy to some extent, for example, night operation and such. Harbor docks, a lot of activity on that front. It remains to be seen how those are commercialized and which one of those will be commercialized. Then, from my personal point of view, is that where we'll be seeing autonomous implementation is non-payload operations. So operations which are not necessarily related to money making of the vessel. So for example, one of these could be empty container collection, which is a hot topic at the moment for certain reasons. Why not utilize autonomous technology there? Why not have autonomous barges collecting empty containers from certain locations and bring them into a centralized location from where you ship them to other part of the world, just as an example. So these are the future outlooks for autonomy. Hopefully this presentation gave you an idea where the industry is at the moment and what kind of technologies are being developed and where we are heading. I would like to thank you for your attention and have a nice day.